3.10 trig equation. We start with sine or cosine of an angle equal to a trig value. And when you think about rewriting this, then we can put this one in to inverse of sine. So this output becomes input of the inverse, and this sine of x input becomes output because these two are inverse to each other. When you think about finding sine of x is equal to 1 over 2, yes, sine value, sine of an angle equal to 1 over 2, then you're getting 1 over 2 from first quadrant and 1 over 2 from second quadrant. So actually there are two answers, theta equals to or x equal to pi over 6 or 5 pi over 6. But then when you think about what we did last time when we restrict domain, then due to domain restriction, inverse sine, I told you that we are only in quadrant 1 or 4, and because this one's positive, we need to be in quadrant 1. That means we are getting only one answer, pi over 6 only, which is this one. So I had a 2 answer, but then this one didn't count for inverse because of domain restriction. But then if we don't put the domain restriction, then we are going to get infinitely many solutions. So when you look at sine, x equal to 1 over 2, meaning unit circle value sine 1 over 2 happen here and here, because when you think about this order pair, radical 3 over 2, 1 over 2, and this blue one gives me negative radical 3 over 2, 1 over 2. So when you focus on sine y value 1 over 2, then I'm getting these two. First answer is pi over 6. But then when you think about coterminal angle for pi over 6, then you get pi over 6 as an answer, but when you make one full rotation and pi over 6, that can be second answer. When you do 2 rotation and pi over 6, 3 rotation, 4 rotation, you have infinitely many solutions. So one of the way you can put this one in notation is pi over 6 plus 2k pi. 2k represent coterminal angle, and k represent how many rotation I'm getting. So let's say if you have 2 rotation, then this will be 2 pi. You rotate 2 pi twice, which gives you 4 pi, and then pi over 6. Similar thing happened for second answer, 5 pi over 6. So when I start from the x-axis, 5 pi over 6 is this angle. But then when you think about 1 rotation and 5 pi over 6, or 2 rotations and 5 pi over 6, then again you have infinitely many solutions. And again, k has to be integer so that you can make multiple rotations. Not just a sine, but then when you look into cosine, then you are getting infinitely many solutions if we don't restrict our domain. Cosine x equal to 1 over 2. When you think about cosine value, then quadrant 1 positive, quadrant 2 negative, quadrant 3 negative, quadrant 4 positive, negative. And when you focus on cosine, meaning x value positive happen here and here, then I am getting cosine 1 over 2 happen this one, which is 1 over 2, radical 3 over 2. Then, and one more in fourth quadrant gives me, this one gives me 1 over 2, negative radical 3 over 2. So when you focus on these two, then first angle measure I'm getting is pi over 3 in first quadrant. Second answer for red, I'm getting 5 pi over 3. But again, when you think about rotations, then we have infinitely many solutions doing coterminal angle. So plus 2k pi for both of these two answers. How about tangent? When you think about tangent, x equal to 1. Tangent is sine over cosine. So when you do sine over cosine, I am getting 1, meaning 1 over 1. Actually, you have to have radical 2 over 2 over radical 2 over 2 to get 1 over 1. And when you have negative over negative, you are still getting positive 1. So radical 2 over 2 happened here, which is 45-degree family, pi over 4. Second one happens here with negative radical 2 over 2, comma, negative radical 2 over 2. So when you find sine over cosine, then tangent of 5 pi over 4 gives me negative over negative, gives me positive 1. So I have actually, this angle is 5 pi over 4, 5 pi over 4. So when you think about putting same notation from sine and cosine, then actually I'm getting two answers with x equal to pi over 4 plus 2 k pi or pi k from green. When you do same thing for blue, then I'm getting x equal to 5 pi over 4 plus 2 pi k. But then for tangent, instead of doing 2 pi k, when you think about starting in here, and next answer should be this one, and you are keep going back and forth between these two. So instead of doing 2 pi k, you may change this into 1 pi k from pi over 4, and then you don't have to worry about this guy. So that's how you get this answer, where the k is an integer. Since the period of, another way to explain this is since the period of tangent is pi, one equation covers both of these two. It looks similar to what we were doing from inverse, but then we don't restrict any domain. So I'm getting infinitely many solutions by putting plus 2 pi k or plus 1 pi k for tangent. Let me do some example questions. Example 1. Here, you see we don't have any restrictions, so don't worry about putting quadrant 1 or 2 like we did in inverse cosine. But for this one, I want you to think about how to get this angle by looking into unit circle value. Radical 2 over 2 comes from 45-degree family or pi over 4 family. So when you look into cosine negative, then cosine negative happen. Yes, let me put it one more time, and then here when you put it in quadrant signs, then cosine negative happen here and here. And when you think about this trig value, then I need to be in second quadrant 45-degree family and third quadrant 45-degree family. Meaning first answer, this answer is 3 pi over 4 from initial array. And when you do the same thing for this one, second one, then I travel this much, which is 5 pi over 4 from unit circle. How would you put your answer? I want you to put this answer with a theta, angle theta. Angle measure, first answer is 3 pi over 4. But then I don't have only one answer, but I have infinitely many answers if we don't restrict our domain. 1 rotation and 3 pi over 4, or 2 rotation and 3 pi over 4, or multiple rotations and 3 pi over 4, those coterminal angle have same cosine, same trig values as an answer. So you can put this one as 3 pi over 4 plus 2 pi k or k pi, and you need to show where k is an integer. Yeah, I put parentheses here, but actually you don't need to. Where k is an integer. Second answer from blue, this one is theta equal 5 pi over 4, but then again, 1 rotation and 5 pi over 4, or multiple rotation and 5 pi over 4, you need to show that. So 5 pi over 4 plus 2k pi. So this entire thing is my answer. 3 pi over 4 plus 2k pi, theta equal to 5 pi over 4 plus 2k pi, where k is an integer. Let me move on to next one, example 2. Sine -1. Sine -1, I only have one answer. So when you look into quadrantal, then this one is 0, -1, meaning when you travel this much, then I am getting sine y value -1. This answer is 3 pi over 2. My answer, x equal to 3 pi over 2. But then this is not only answer. You may have multiple rotations and 3 pi over 2 more. So 3 pi over 2 plus 2 pi k, where k is an integer. This is answer for example 2. Move on to example 3. Tangent equal to 1 over radical 3, but actually you need to put over 2 over 2. Yeah, 1 over radical 3 is simplest form. So actually when you go back, then we had 1 over 2 over negative radical 3 over 2. Maybe you had the negative and then turn into positive, so you gotta consider that one too. Where this one is a sine value and denominator cosine value, so you look into both of sine and cosine and plus and minus to figure out tangent value of 1 over radical 3. When you focus on one of this one, sine value, then you're going to see when you are at 30-degree family with radical 3 over 2, 1 over 2, I'm getting 1 over 2 over radical 3 over 2, so this is my first answer. First answer, pi over 6. Again, I ask you to consider negative as well, so you need to consider this negative. Negative radical 3 over 2, negative 1 over 2, gave me negative over negative, gives me same answer. So second answer is 7 pi over 6. 7 pi over 6 in quadrant 3. So I have 2 answers. But then this one, I can show you how to combine this one again, because for this one, you're getting pi k. So first answer, yeah, I'm getting pi over 6 from blue plus 2 pi k, where k is an integer. Integer meaning 1, 2, 3, or 0, -1, -2. Those shows us infinitely many answer with coterminal angle. Second answer, x equal to 7 pi over 6. 7 pi over 6 plus 2 pi k. Yes, you may leave answer like these two different, but then when you look into relationship in these two, Then from pi over 6, when you add by 1 pi, then you're getting second answer. When you add another pi, then you're getting the third one and the fourth one. So you may change this answer into, get rid of this one, and you may change into x equal to pi over 6 plus 1 pi k as a final answer. So this can be the answer. Or you need, if you want to put both of them, then these two are the answer. Yeah, just follow when you're taking the assessment. Follow what question asks you to do. Either simplify into this way, or you have two answers from two angles. This is a step to solve trig equations. When you see general solution, I was putting my answers in general solution. So these are general solution. When you have 2 pi k or 1 pi k, this is called general solution. So what we are going to do is, number one, isolate one side of the equation, and you're going to find two corresponding angle measures from unit circle. And number three, consider any domain restriction, and then put your answer in general solution. Those are 4 steps. Let me look at example 4. What are all values of theta? Meaning I do not have any restriction on this. So when you look at this one, I want to solve for theta itself eventually. But then theta is inside of sine, so we need to use unit circle value. Before, I don't want this 6 in front of sine, so let me divide by 6 both sides. Meaning 6 cancel out, and I'm getting sine of theta is equal to, I'm getting 3 radical 2 over 6. When you simplify this, then I'm getting 1 radical 2 over 2, which is same as radical 2 over 2. Sine positive happens in first quadrant and second quadrant, and this one comes from 45-degree family, meaning first answer angle measure should be pi over 4, and the second one is 3 pi over 4. So 2 answers. Angle theta is equal to pi over 4 plus 2k pi, where k is an integer. Second answer in red, I'm getting 3 pi over 4 plus 2k pi, where k is an integer. This is my answer. Can I change this into 1 pi k? When you have, when you can simplify into 1 pi k, your answer has to be 1 on this side, and the other one should be opposite direction from the origin. So when you have like period of pi, then you may put this one into 1k pi. But the problem for this guy is my first answer is here, and second answer is right here. And then after that, I need to travel this much. So your pattern is not 1 pi, so you may not simplify into 1k pi. This one doesn't work for this one. But then when you look, go back to this answer, then my first answer was here, second answer was here. So your pattern is 1 pi. That's why you can simplify it into 1 pi k. So not always, you may simplify into 1k pi. You need to look into the pattern with it. These are the answers for example 4. Let me move on to example 5. I have f over x and I have g of x, 2 different functions. And question is asking, find the point of inflection. And there is a restriction in theta 0 to 2 pi, which is 1 full cycle of unit circle. So when they're intersecting, point of inflection, meaning f of x and g of x, those value, or x value and the y value have to be equal to each other because they are intersecting. So I'm setting them equal, meaning f of x, 3 plus 2 cosine theta is equal to g of x, which is 2. When you set them equal to each other, then again, I am going to find theta itself. So I want to find theta itself. You need to do some, multi-steps to simplify this. First, I want to subtract by 3 both sides. Then I'm getting 2 cosine theta is equal to 2 minus 3 gives me -1. Now I want to take care of 2, so divide that by 2 gives me cosine theta is equal to -1/2. And from here, yes, I do have a restriction from 0 to 2 pi. I want to make this into unit circle. Cosine negative happen in second quadrant and third quadrant. And first answer is 60-degree family, 2 pi over 3. Yeah, can I do 2 pi k for this one? No, I cannot, because my restriction is from 0 to 2 pi. So if you are adding by 2 pi, then you are over 2 pi already. So that's first answer. Second answer, this one, it gives me -1/2, comma negative radical 3/2. And the angle measure is 240 degrees, which is same as 4 pi over 3. So these two are the answer. Yeah, I cannot put 2 pi k because, yes, you cannot find the coterminal angle for this one. To restrict domain from 0 to 2 pi. Let me move on to next part. When you think about squaring x, then we just put like x squared. But then when you are squaring sine x, then you gotta be careful with notation, because when you think about putting sine x squared like this, actually this one represents sine of x times x inside of the parenthesis. So when you actually square the sine, I'm talking about sine x quantity squared, then you may want to put it like this, which is same as sine of x quantity square, or this may put it in as a sine of x, and then you put square in between sine and x. This represents sine x quantity square. So you're going to see sine x square is not same as sine square x. Yeah, this is sine x quantity square, while this one here is sine of x times x inside of the parenthesis. So this part, yeah, let's try to show you the notation with it. And example 6, we are doing a similar step, but then because sine is squared, we are going to use a square root to figure out the angle measure. Questions asking you to find 0 and restrict domain from 0 to 2 pi, meaning I'm going to set this one equal to 0. Then I'm getting, let me rewrite here, 3 minus, or yeah, can I do 0 equal to 3 minus 4 sine square x? These are solving, and I want you to put sign on one side and number on the other side. So let me add the 4 sine square x both sides. Yeah, basically you're moving this one to the other side. So from here, these two cancel out. I'm getting 3 on the right, and I'm getting 4 times the sine square x on the left. I want to take care of 4 by dividing by 4 both sides. Then when you divide by 4, but then you cancel out. So I'm getting sine square x, or yeah, this is same as sine x quantity square is equal to 3/4. And from here, I want to get sine x itself, meaning I want to put square root on here and square root on here. When you put square root, don't forget to put plus or minus. We learned that one from algebra 2. Sine x from inside of this, square root and square, you can think about canceling those out. And I'm getting radical 3 over radical 4. when you try to simplify denominator, then this radical 4 becomes 2. So from here, I'm getting 2 answers. 1 sine x is equal to positive radical 3 over 2. And second answer is sine x is equal to negative radical 3 over 2. And I want you to know, from each of these two, you may get up to multiple answers. I want to say usually 2 from unit circle. You are getting multiple answers, so make sure you don't miss any of those. First one, let me look at sine value radical 3 over 2. Sine's positive in quadrant 1 and 2. I think happening in 60-degree family, so I have 2 answers. First answer, this one gives me pi over 3. Can I do plus 2k pi? No, I may not, because I have a restriction. No 2 pi k for this. Second answer is this one. Second answer is 2 pi over 3 from here and here. So 2 answers from positive radical 3 over 2. How about negative answer? Negative answer, you need to look into unit circle again. Sine is negative in third quadrant, fourth quadrant. When you think about doing 1, 2, 3, then negative radical 3 over 2 is here and here. So this angle is 4 pi over 3. And the second one, this guy, second one is 300 degrees, 5 pi over 3. If you need to, make sure you go back and review unit circle value. You need to be really quick finding these answers. So 2 from positive, 2 from negative. So total, I have 4 answers. You need to find all 4 answers. 4 answers. Let's move on. Example 7. One of the careless mistake, or the mistake I see, is dividing by cosine and dividing by cosine and making to cosine theta is equal to -1. No, that's not correct. I want to put it in here. You are going to factor this. Do not divide. I'm going to use factoring. When you divide, then you are missing one side, and you may not get all answer that we had. Like this one, you had 4 answers, right? When you divide, we only get up to 2 answers. So it looks like you can divide from both sides, but then you may not divide. Do not divide. But rather, I want you to make this one into, make it into 0 on one side. Meaning, I want you to add by cosine theta from both sides. Then these two become 0. Then on the left side, I'm getting cosine squared theta plus cosine theta. Cosine square and cosine to the first, you may not combine. It's like x squared plus x. Can you combine these two? No, you may not. But actually, you may factor this one out. Take cosine out as a common factor. Then you may get cosine theta. You may check it. When you multiply these two, am I going back to square? And when you multiply these two, I'm going back to this, which will be 1. So these are what you're getting by factoring it out. Factor this one out, plus 1, and so equal to 0. Factoring, okay? From these two terms, I take cosine out, and then this is the remaining term, and when you multiply these two, then going back to cosine x. We did similar thing in algebra 2 last year. Let's say, here's the example. Let's say I have x minus 1 times by 2x minus 1 is equal to 0, and when I ask you to find satisfying x value, then from here, by setting equal to 0, then I'm getting 1. by setting this equal to 0, I'm getting 2x minus 1 equal to 0, so x is equal to 1 over 2. That's how you find x value from this factored form, right? I'm going to do a similar thing. What I'm going to do is I'm going to set this equal to 0 and set this guy equal to 0. So actually I have two things right here. So let me separate it here. First one, when you set cosine theta equal to 0, first parenthesis equal to 0, then you are getting angle theta up to 2 answers. And the second parenthesis, this guy right here, cosine theta plus 1, and you set it equal to 0. Then I'm getting 1 answer from this one. So let me look into this guy, unit circle. Cosine 0, quadrantal, I think we are on 0, 1 here, and 0, negative 1 here. We are restricting domain in 0 to 2 pi, so we are not doing plus 2k pi for this one. You may not. Cosine 0 meaning here and here, so I'm getting 2 answers. Pi over 2 from y-axis, and 3 pi over 2 from other y-axis, quadrantal. What about blue? Cosine theta plus 1 is equal to 0, meaning cosine theta is equal to negative 1. So when you think about negative 1 for cosine, then I'm here, which is pi. How many answers total? From here, I'm getting 3 answers. Did you get all 3 answers? Again, if you divide, you may not get 3 answers. I don't want you to even try. Do not try to divide. Follow what I am doing, and you need to get 2 different cases from parentheses, and then by setting equal to 0 from unit circle value, multiple answers. In this case, I'm getting 3 answers. Number 8, example 8. Again, this question is asking you to find point of intersection where f of x and g of x, you are setting them equal to each other. Again, do not divide. I'm talking about divide by like sine x or cosine x. When you have a leading coefficient, you need to divide, but then I'm talking about dividing by sine or cosine. That's not okay. F of x is 2 sine square x, and g of x is radical 3 sine x. And you see, you have a temptation to divide by sine x, but I told you to not. Rather, I want you to make this one into 0 on one side. How would you do it? You subtract by this guy both sides, minus radical 3x minus radical 3 sine x. When you subtract by this both sides, then these two cancel out to 0. And these two, I'm getting, let me write it down here. 2 sine square minus radical 3 sine x. That's what I have. 2 terms. Common term is sine x. Take out sine x. I'm going to use factoring. You need to use factoring. When you multiply these two, going back to 2 sine x, so you need to have a remaining term 2 sine x inside. Minus, when you multiply these two, then I'm going back to this. So this one has to be minus radical 2. Again, you may put this one in the parentheses, like x minus 1, x plus 3 in algebra. Then I'm getting x equals 1 from here, and x equals negative 3 from here. By setting this equal to 0, this parenthesis equal to 0. That's how you get this, right? I'm going to do the same thing. So set this entire thing equal to 0. 2 sine x minus radical 3 equals 0. And first parenthesis is set equal to 0, meaning I'm getting sine of x equal to 0. And from here, you're getting multiple answers. This is algebra. Let me erase this one. Sine x is 0. Sine 0 is here and here. When you look at the restriction, then you start from 0, you do not include the 2 pi, so 2 pi may not be the answer. When you put it here, 0, pi, and 2 pi, because of restriction, you need to exclude this guy. So from red, I'm getting 2 answers. From blue, yeah, probably 2 answers again. When you're solving for x itself, then I want to do 2 sine x is equal to positive radical 3 by adding radical 3 both sides. This division is okay. You're divided by a number, that's fine. I ask you not to divide by sine or cosine. Do not divide by sine over or cosine. Yeah, that's illegal. When you divide, I'm getting sine x is equal to radical 3 over 2. Radical 3 over 2, sine is positive in first quadrant and second quadrant. Yeah, you may try to expedite this process by mastering unit circle. So 2 more answers, pi over 3 from this one, and second one should be 2 pi over 3. So did you get 4 answers? Yeah, by not dividing by sine or cosine from both sides.